Okay, so the last one we left off at was getting to our KSP expression. And this is pretty typical of how these problems work, in the sense that you're going to go through essentially 3 parts every single time, and that you have to set up that ice chart, okay, get those ending expressions, and then show me that you understand that that's telling you something about how that relates to the KSP. And then the last thing is, okay, we got to finish off this monstrosity in terms of isolating X, solving for X, and then evaluating for that the molar solubility. Here's where we're at with our expression. And KSP was given to us, and it's a small number. Again, these are always going to be small numbers. And we can now proceed with the algebra part of our problem. If we just take and distribute that 4x squared in here, we're going to end up with this. Okay? And there's some terms in here, an x squared term, an x cubed term, and this could be pretty hairy if we really wanted to solve this, you know, to the letter of the law in terms of algebra. What we need to remember here is that x is small for these. Okay? Look at our KSP. Okay? That's 10 to the minus 11. X is also going to be a very small number. And when you take a really small number and you square it, you get a really, really small number. And when you take a small number and cube it, by comparison, this value is going to be minuscule compared to that x squared value. So for that reason, we can just ignore this term. Okay, that's just going to drop out completely. And the reason we can do that is because when you take x that's already a small number and you square it, you get a really small number. When you cube it, you get an even smaller number that really doesn't make a difference. And by the way, you can go through and you can show yourself at the end. If you don't trust that, you can actually go through and evaluate both ways and see, okay, based on that value of x, yeah, that is really small. And we were okay to ignore that value. And so if we just go ahead and proceed now with our much simpler expression, right, we're just going to go through, right, and evaluate this. Okay, that's going to take care of this part of it. And then to get to x, we're going to solve by taking the square root of our KSP divided by 0.012. And at the end of it all, you will end up with this value, and this is a molarity, okay, because this is molar solubility. Okay, so, you know, roll with the punches as you're setting this up. Get to your expression, and then when you have ridiculous terms with, you know, a very high exponential value, you're only going to retain the smallest one. If you end up with just an x term versus an x squared term, then you would eliminate the x squared term. And that's the sort of simplification we can make when you're dealing with super tiny numbers.